Hi, and welcome to Lesson 22, Airports, Airspace, and Flight Information. We are going to assume private pilot knowledge as we cover these subjects and focus how they apply to IFR operations. If you're still finishing up your private, or if it's been a while since you've studied this material, make notes of questions and areas where you need additional study as we go through this video. As always, this video will give you a guide as to what you need to study, but it won't be enough all on its own if you just watch the video. You're going to need to do the reading and review any areas that you feel weak on. We'll start with airport markings. Airport markings are required as part of the private pilot studies, but now you need to review and sharpen this knowledge. The basic information about runways becomes more important when you're orienting yourself on a rainy night. You will need to study all of Chapter 2 in the AIM in detail, because many of the details could make the difference as you struggle to find your way under IFR. You'll be responsible for identifying any or all of the runway features on this and the following slides. Many of these you should already know, but things like how many stripes are on the threshold marking are details you may not have needed as a private pilot. Knowing this allows you to gain some situational information quickly, though, in conditions where visual illusions are real risks. Here is a question for you. How many threshold stripes does runway 13 right, 31 left have at Hillsboro? Expect that to be on the pop quiz in our next class. Displaced thresholds come in two flavors. One like this that you can taxi on and off of, and blast pads where the aircraft should never be. Blast pads are marked with these chevrons. Sometimes you may see other arrangements of runway thresholds where there's the taxiway that actually goes out onto the runway pavement and is aligned with the runway. Remember, yellow paint means ground ops only. It's still a taxiway until you get to the white, and that means you can't take off on it. Taxiway markings are yellow. The continuous lines show the boundaries of the taxiway, and dashed lines show aprons. There's a trend towards developing enhanced lines by painting a black background and sometimes adding enhancements to alert the pilot when they are approaching the hold short line. It's important to understand the difference between a movement area, where you have to be in contact with ground control, and a non-movement area, where you don't. The terms are confusing, but remember they are from the perspective of the air traffic controller in this case. A movement area is where ground control is responsible for the movement of aircraft. A non-movement area is where they're not responsible for it. Keep in mind also that at bigger airports, non-movement areas may be controlled by somebody other than the FAA air traffic controller, such as a ramp agent. If that's the case, there'll be a frequency published for ramp control. This is especially confusing at Hillsboro Airport because the non-movement portion of the ramp is huge. The movement area boundaries near HAA are actually here. There's a movement area boundary here and here. Everything on this side of the movement boundary is a non-movement area. That means that technically you could taxi from the Hillsboro ramp out to the run-up area without contacting Hillsboro ground. We have a letter of agreement between Hillsboro Aero Academy and the Hillsboro ground control that says we will call them up before we move out there, but it's not required. If you were a transient pilot and parked over here at the terminal and you didn't know about that agreement, you would be perfectly within your rights to taxi from there out to the run-up area, do your run-up, and then only contact ground when you encounter that movement area border. Hold position markings are located wherever a taxiway intersects a runway and to indicate where an aircraft is supposed to stop when approaching the runway. You will also find them on the runway where a land and hold short clearance is approved. For both hold short lines and movement area boundaries, you can move without permission from the dashed side to the solid side, but you cannot move without permission from the solid side to the dashed side. You can remember that the solid lines form a wall that you cannot get past, whereas the dashed line has gaps in it where you can get through. Additional markings are often added, especially where potential mistakes are prone to happen. If you see something unusual like this, think about why they would do it. In this case, I might be thinking that it's common for pilots to mistake this runway for another runway since they went to the trouble of putting the runway number on the pavement like this. I'd do a double check and make sure that I'm pulling onto the runway that I thought I was. The most important thing about land and hold short of operations, or LASSO, is that they're optional. If you, the pilot, determines that it isn't safe, you can reject the clearance. If you accept it, though, you have to do it. So don't accept it unless you know for sure that you can do it. You can still go around if you're cleared for a landing with a LASSO restriction, though. There will be a hold line on the runway prior to the crossing runway that you're supposed to hold short of if you're doing a LASSO operation. Since you're going to be flying in instrument conditions, you're likely going to be issued taxi clearance that has you holding at the ILS line in order to keep from interfering with the signal as other aircraft use the approach. This is something that you may not have encountered yet as a VFR pilot. Mandatory signs have a red background with a white inscription. They can be used to denote an entrance to a runway or a critical area or areas where an aircraft is prohibited from entering. Just remember, red means stop. Location signs are on a black square with a gold outline. Black square, you're there. Just remember that the runway remaining signs are slightly different. They don't have the border. Here are a couple of examples of those. The distance remaining markers become important when you're landing on wet or icy runways, so you need to start noticing them when you're on the runway. Direction signs are there to give you, well, directions. They point the way to something, whether it's a taxiway or something else. Destination signs are similar, except they represent what is typically somebody's destination or the end point of their taxi journey. Challenge yourself to be really familiar with all these signs and put some energy into noticing each one as you move about the airport. If you ever see one that you don't know, ask about it. If you see something challenging out there at one of the airports while you're flying around, snap a picture of it and bring it back. We can go over it in class. Airport lighting is also about to become a lot more important to you. It's the AIM Chapter 2 that covers this for you. This is where color vision becomes really important. Make sure you've got all the colors down pat in your mind. Taxiway edge lights are blue. Taxiway lead-on and lead-off center lines are alternating green and yellow. Bidirectional lights that mark the far end of the runway are red for pilots that are taking off or on their landing roll, and green for pilots that are approaching the threshold for touchdown. So for landing, you have to clear the green row of lights that mark the beginning of the runway before you touch down, and stop before you get to the red ones. Sometimes you'll see a pair of white strobes at the end of the runway to help you find the end of the runway, and we call those runway end identifier lights, or rails. They are often the first thing you see on an approach that doesn't have approach lights on the runway. White lights outline the edge of the runway to help the pilot see the edges of the pavement in low visibility conditions. On instrument runways, the white runway edge lights turn yellow for the last 2,000 feet or the last half of the runway length to form a caution zone for landings. Centerline lights are white, and that helps the pilot see the center line of the runway in low visibility conditions. The centerline lights on both runways and taxiways are flush with the ground so that you can roll right over the top of them. When viewed from the landing threshold, the runway centerline lights are white until the last 3,000 feet of the runway. The white lights begin to alternate with the red for the next 2,000 feet, and for the last 1,000 feet of the runway, all the centerline lights are red. The yellow runway edge lights and the red runway centerline lights are there to help you know when you're running out of runway at night when it's hard to see the runway remaining signs. Some runways have additional lights in the touchdown zone to help you find the touchdown on the landing. Approach light systems help you see the runway environment just a little bit sooner in low visibility conditions so that you can start transitioning to visual cues from your instrument reference. There are a variety of them. You need to be familiar with your names so that you know what to expect when you break out. If you don't know the difference and have been operating to an airport with MALSRs, for instance, then shot an approach to a runway with LAS F1s, you might think you are closer to the end of the runway than you really are, which could lead you to reduce power for the landing prematurely. Many CFIIs require their students to be able to draw them from memory, but you should at least know their basic shape and size. PAPI and VASI have been around for a long time. The standard 3-degree glide slope that they are aligned to on a standard runway correspond to typical instrument approaches. You should learn and discipline yourself to follow these in preparation for instrument flight. Don't forget your pilot-controlled lighting. Many pilots have flown approaches to uncontrolled fields at night only to go missed because they forgot to activate the lights and therefore couldn't see the runway. There are times under IFR when you'll accept a visual approach or a contact approach, and it will be important to spot the airport. The beacon is usually the first thing you'll see, and it's important that you understand and be able to recognize the different types of beacons. Also be watchful for red lights flashing or otherwise near airports. They identify obstacles that might be a factor for you during a circling approach to land. Runway incursions continue to be an issue that the FAA is focused on. An incursion can happen in movement areas in which case they are a surface incursion, or a runway, in which case they're a runway incursion. They come in 4 levels of severity, starting with D as the least hazardous, and rising to A, which means an accident was narrowly avoided. A hot spot is a location on an airport movement area with a history of potential risk of collision or runway incursion. And they're highlighted to get your attention on the airport diagram. You can find these circled in brown there. Review all the hot spots prior to flying to any familiar airport or before taxiing. You can avoid most of these incursions by having your airport diagram out and using it. The newest diagrams include the hotspots as well as other useful information. Use your heading indicator in conjunction with signs, markings, and other tools to stay oriented. Maintain a sterile cockpit during all taxi operations and focus on the task. If you're unsure what to do, stop and ask. Now let's talk about airspace from an IFR perspective. As an instrument pilot, we have 2 concerns relating to airspace. Number 1 is if we ask for a clearance into an area, are we likely to get it? And 2, what sort of VFR traffic activity can we expect to be there, and how close to the clouds are they going to be flying? There's nothing new here in terms of the names and the rules for the different classes of airspace. It's just that you're using the airspace differently. Controlled and uncontrolled airspace does not refer to whether the communications are required. It has more to do with how we separate aircraft. These terms go way back to a time when airspace was uncontrolled all over. There were few airplanes, none of which had the instruments necessary to fly in the clouds. Traffic density even at the busiest airports was very low, and the airplanes flew very slowly. Although there were no standards for weather conditions the aircraft could fly in, it was generally agreed that you could, as long as you remained clear of the clouds and at least had 1 mile visibility, you could see other airplanes and terrain in order to avoid the collision. This was called see and avoid, and it formed the basis for VFR flight and remains critical to preventing collisions. With the advent of gyroscopic flight instruments, travel through the clouds became possible. See and avoid was useless in the soup, so procedures to ensure aircraft separation were needed. This led to the creation of air traffic control, or ATC, and controlled airspace, what is now called Class E airspace. The government established a system of airways, each 8 nautical miles wide with base altitudes of 1,200 feet above ground level, and designated the airspace within them as controlled airspace. The airway system was defined by a network of radio beacons, many of which were located on airports. Radio communications were not required in this airspace for VFR flight, but air traffic control kept track of who were flying in the clouds in that airspace and did their best to separate them. They didn't have radar yet, but they kept track of who left where, when, and how fast they were going, and they didn't clear any 2 airplanes to fly in the clouds at the same time in a given airway or control area. More stringent weather VFR minimums were established for this controlled airspace to further separate traffic so that aircraft popping out of clouds had a fighting chance to see and avoid other aircraft that were operating VFR and therefore not in communication with ATC. In poor weather conditions, pilots and aircraft had to be qualified and equipped for IFR flight, file IFR flight plans, and coordinate their positions with air traffic control. When weather conditions were good, pilots could still fly on IFR flight plans if they chose, but were responsible to see and avoid other aircraft. This is still true for us in most cases. Some parcels of airspace contained many airways, so in those areas, controlled airspace was established at 1200 AGL to coincide with the airways, whether on an airway or not. When VOR airways arrived in the 50s, they were and still are known as Victor airways. Controlled airspace does not mean that all flight within it is controlled. It means that IFR services are available to qualified pilots who choose to use them. Pilots operating under VFR may fly freely in controlled airspace as long as the weather meets certain minimums that apply to that airspace. Airport-based radio navigation facilities made instrument approaches possible, greatly improving the utility of aircraft and also creating some traffic separation challenges. Close encounters between IFR airplanes on approach to VFR airplanes flying under the weather led to creation of some transition areas. Transition areas surrounded airports with instrument approaches and brought the Class E airspace down to within 700 feet of the surface. This move was intended to protect IFR pilots. Pilots flying under VFR could operate in the transition areas as long as they had VFR weather. These are still there, marked by the fuzzy magenta bands on the sectional. To help pave way for all-weather utility, the ILS was invented, or Instrument Landing System, providing vertical guidance in the form of an electronic glide slope. It remains the predominant precision approach system today. The ILS brought airplanes to within 200 feet of the ground, and that caused more problems with the VFR flight around the airports with precision approaches. The solution was to bring Class E, or controlled airspace, to the surface and to raise the minimums so that VFR traffic was restricted during poor weather. As an instrument-rated pilot, you can ask for and get clearances to fly in all controlled airspace. ATC will not clear you to fly in uncontrolled airspace. You could fly in uncontrolled airspace, IFR anyway, without a clearance, if you're sure no one else is there and you're instrument rated and instrument equipped. But it's seldom necessary these days, except perhaps a quick climb from a small airport to 700 or 1200 AGL, where you can operate with a clearance. As traffic increased at major airports, the need for air traffic control towers became apparent. Controllers in the tower were, and still are, responsible for sequencing arriving and departing airborne traffic and keep things in order on the ground. Don't confuse the word controllers with controlled airspace, though. As we've seen, there's lots of controlled airspace where pilots are not required to talk to controllers unless they are operating IFR. Class D airspace was established around towered airports, and all pilots operating within it were required to communicate with the tower, regardless of weather conditions. The same weather minimums apply in those Class D airspace as applies to the Class E surface airspace. This assures the IFR pilot that they won't face any nasty surprises as they pop out of the clouds on the approach. Class G is uncontrolled airspace. It can extend from the surface to a maximum of 14,500 MSL. Everything above that is controlled airspace. You have to look a long ways out in the boonies to find Class G airspace that extends all the way up to 14,500 nowadays. In most cases, Class G only extends up to 1200 or 700 AGL. Max speed is 250 below 10,000 feet. An instrument rated can fly IMC in uncontrolled airspace, but they will not receive ATC clearances for it. Class G that extends up to 14,500 is depicted in brown on the IFR low en route charts, such as this one. As I prepped this video, I decided to check for nearby Class G airspace on our chart. Though there's a little in Canada just across the border, you have to go east all the way to Duluth to find it at our latitude in the US. There was a lot more just 20 years ago, but with the move towards RNAV, where pilots can cut across country off airway, it made sense to get rid of most of it. There is, of course, still Class G low to the ground, again topping out at either 700 or 1200 AGL, unless the Class E goes all the way to the surface around an airport with an instrument approach. You do still need to know that, unless designated at a lower altitude, as is usually the case, Class E begins at 14,000 feet, as well as the airspace overlying the waters within 12 nautical miles of the coast, and it goes up to, but not including, 18,000 MSL, at which point Class A starts. There is also Class E above flight level 600, though it's unlikely you're going to have to worry about that unless you're wearing a spacesuit. Max speed is 250 knots below 10,000 MSL. It's worth noting that Class D is not depicted on the en route chart, and Class C and B are only depicted as a big shape with none of the sector information. That's because if you're IFR, you're already on a clearance and talking to somebody, so you shouldn't have to worry about it most of the time. The one common exception to having to worry about it is when switching to tower from approach. If approach forgets about you and you're about to cross into the Class D airspace, you need to ask and switch. Most towers don't care if you're a little late, but some do. Aurora Tower, for instance, has reported a number of pilots recently because Portland Approach didn't hand them off in time. We've talked to Portland Approach about this, and they say they don't have a problem with you switching to Aurora Tower without asking if the frequency is too busy. As an IFR pilot, the weather minimums are important, again, for two reasons. First, you're still going to want to cancel and go VFR sometimes, and you need to know the rules so you know when it's safe and legal to do it. Second, it pays to know how close to the cloud you're flying in the other traffic might be when you pop out, and also whether it's good enough for there to be VFR traffic out there at all. Up higher, the cloud clearances and visibility increase because the speed limit increases, meaning that you could be in a Learjet and pop out of the side of a cloud at 450 knots. In Class Delta airspace, you have to establish two-way radio communication with ATC prior to entering. That means that you must have called them and the tower has to have responded with your tail number. Max speed in the Class Delta airspace is 200 knots within 4 nautical miles of the airport. Generally, they go from the surface to 2500 AGL. On low en route charts, Class D airports are denoted by putting a letter D in a box next to the airport identifier. Class D weather minimums are the same as Class E below 10,000, 3 statute miles, 500 to below, 1,000 above, 2,000 to the side. With Class Charlie, the inner ring of Class Charlie airspace extends from the surface to 4,000 and has a radius of about 5 nautical miles. The outer ring typically extends from 1,200 above the airport to 4,000 above the airport and has a radius of about 10 miles. The shapes may vary, and the general overall shape is depicted by a blue shaded area on the low en route chart, but they won't have the sector details that you're used to seeing. Two-way communications is needed to enter, and you have to have a transponder with altitude encoding in order to be either within the Class C or above it. Max speed is 200 knots within 4 nautical miles of the airport. Class C weather minimums are pretty much the same as everywhere else, so 500 below, 1,000 above, 2,000 to the side, and 3 miles visibility. Once you've got your instrument rating, Class B isn't so scary anymore because you're already talking to them and you'll fit right in with the other operations a lot better. The communications might be a little bit faster paced, but you're playing the game that they want it, the way they want it to be played as an IFR pilot. Because everybody is on a clearance in Class B airspace, we don't have to worry about separation as much. The air traffic controllers have the obligation to separate all the aircraft. So VFR traffic just has to remain clear of the clouds. Inside the Class B, we can go faster if we're in a faster airplane. We can go 250 knots. Class A starts at 18,000 and again goes up to flight level 600. Everybody in Class A has to be on IFR. DME is also required above flight level 240, and you can go as fast as you want up there, as long as you stay under the speed of sound, at least for now. There may be times when special VFR comes in handy as an instrument pilot, and once your instrument rated, you can use it even at night. Special VFR can be requested anytime you're in controlled airspace below 10,000 feet. It must be pilot requested. ATC will never offer this unless you ask. I've heard many radio conversations where pilots were trying to get into the Class Delta airspace and were apparently waiting for the tower to offer special VFR. But since they didn't ask, they didn't get it, and therefore they couldn't enter the Class Delta airspace. Under special VFR, you need to remain clear of clouds and maintain flight visibility of at least 1 statute mile. You also need to hold a private pilot certificate, and you can only operate special VFR between sunrise and sunset. A current instrument rating and an instrument-equipped aircraft allow you to get special VFR after sunset. Remember though that under these weather conditions the tower can only let 1 aircraft in at a time unless they have one in sight, so don't bank on getting a special clearance. If there's somebody on the approach, then you'll have to wait. If landing at a controlled airport, you can request special VFR clearance from the tower. In this case, with Aurora Airport, you would request it on 120.35. If you are instead taking off or landing at a non-towered airport that has a Class E surface area, you have a couple of options to get your special. You can call the flight service station and they can contact ATC for you, and then they'll give you a release with a clearance void time. Or you can look up in the approach frequency in your chart supplement and see if you can get ATC from the ground. You can also use the remote communications outlet if there is one nearby. We can use the same methods for picking up an IFR clearance, and we'll talk more about that another time. Let's talk a little bit about the special use airspace. You can remember all the special use airspace types with this acronym, MCPRON. Moving through the MCPRON acronym in order, It reads military operations, controlled firing areas, prohibited areas, restricted areas, alert areas, warning areas, and national security areas. MOAs, or military operations areas, consist of airspace with defined vertical and lateral limits established for the purpose of separating certain military training activities from IFR traffic. Whenever an MOA is being used, non-participating IFR traffic may be cleared through an MOA if IFR separation can be provided by ATC. Otherwise, ATC reroutes and restricts non-participating IFR traffic. MOAs are depicted on en route low altitude charts and are not numbered. However, the MOA is further defined on the back of the sectional charts with times of operation, altitudes affected, and controlling agency so that you can look ahead and see whether it may be a factor for your flight. Controlled firing areas, or CFAs, contain activities that, if not conducted in a controlled environment, could be hazardous to non-participating aircraft. The difference between CFAs and other special use aircraft is that activities must be suspended when the spotter aircraft, radar, or ground lookout position indicates an aircraft might be approaching. There's no need to chart CFAs since they do not cause a non-participating aircraft to change its flight path. A prohibited area contains airspace of defined dimensions within which flight of aircraft is prohibited, just like the name says. Such areas are established for security reasons or other reasons associated with the national welfare. These areas are published in the Federal Register and are depicted on the charts, and the areas are charted with a P followed by a number, such as P51 in this example. Examples of prohibited areas include Camp David, the National Mall in Washington, D.C., and the White House. Restricted areas are areas where operations are hazardous to non-participating airplane and contain airspace within which the flight of the aircraft, while not wholly prohibited, is subject to restrictions. Activities within these areas must be confined because of their nature or limitations that may be imposed on aircraft operations that are not part of those activities. The restricted areas denote the existence of an unusual, perhaps invisible hazard. Penetration of restricted areas without authorization from the using agency may be extremely hazardous. Alert areas are depicted on aeronautical charts with an A followed by a number, such as A680 in this picture, to inform non-participating pilots of areas that may contain high volumes of pilot training or an unusual type of aerial activity. Just exercise some caution in alert areas. All activity within an alert area should be conducted in accordance with the regulations, but you can do it without a waiver. Warning areas are similar to restricted areas. However, they're in areas where the United States government does not have sole jurisdiction over the area. This is typically out over the water, and that extends from 3 nautical miles outward from the coast of the United States, and it may contain activities that are hazardous to non-participating aircraft. National security areas consist of airspace defined by vertical and lateral dimensions, established at locations where there's a requirement for increased security. Pilots are requested to voluntarily avoid flying through depicted NSAs. When necessary, to provide a greater level of security, flights in NSAs may be temporarily prohibited. All aircraft entering domestic U.S. airspace from points outside the U.S. must provide identification prior to entry. Military training routes, or MTRs, are routes used by military aircraft to maintain proficiency. These routes are usually established below 10,000 feet for operations in excess of 250 knots. So, in other words, they're breaking our speed limit. Some route segments may be defined at higher altitudes for purposes of route continuity. Routes are identified as IFR or IR and VFR or VR, followed by a number. MTRs with no segment above 1500 AGL are identified by 4 numbers. So think about that for a second. All the activity on a 4-digit military training route is going to be below 1500 feet AGL. MTRs that may include a segment above 1500 have 3 number identifiers. So if you see a military training route with an IR or a VR and 3 numbers, they could be up above 1500 and be a factor for you. TFRs are something that we have to be constantly aware of. We normally think of the forest fires during the summer, but they can exist at any time of year. The one depicted here is for an NFL football game in Seattle. A Flight Data Center NOTAM, or FDC NOTAM, is issued to designate a TFR. The NOTAM begins with the phrase flight restrictions, followed by the location and the effective time, area, etc. The NOTAM also contains the FAA coordination facility and a telephone number in case that you need to contact them. They should also be part of your standard route weather briefing. TRSAs, or TRSAs, were mostly replaced with Class Charlie airspace back in the early 90s, but there's still a few around. They are areas where participating pilots can receive additional radar services. They're totally voluntary, but it allows the controlling facility to more effectively sequence the VFR traffic. The purpose of the service is to provide separation between all IFR operations and all of the VFR aircraft who choose to participate. A really important aspect for IFR flight, for all the reasons we've talked about today, are the NOTAMs. NOTAMs inform us of threats to our flights that range all the way from airspace closures to the risk of getting shot down to forest fires. NOTAM Ds, or the D stands for distant, includes information such as taxiway and runway closures, personnel and equipment near or on crossing runways, nav facilities, and airport lighting aids that don't affect instrument approaches and things like that. These are available when requested during a standard briefing. FDC NOTAMs are issued by the National Flight Data Center. They contain regulatory information, and that will pop up as temporary flight restrictions, aeronautical chart updates, or an amendment to an instrument approach procedure, which is what we have to worry about. Military NOTAMs are NOTAMs pertaining to the Department of Defense, nav aids and nav airports that are part of the NAS military operations area. Pointer NOTAMs are issued to point to additional information such as another NOTAM or the chart supplement, etc. They're there to highlight or cross-reference information so that you can find it. For more details on the different types of NOTAMs, I've put up a primer from the FAA with the different types of NOTAMs in content under the airports and airspace module. I recommend that you go check that out. The Terminal in Procedures publication, or TERPS, is probably the most important piece of information for IFR pilots. The instrument procedures are part of FAR Part 97, so they are actually rules, not just suggestions, and they are updated every 56 days. You can access them through your ForeFlight subscription, or you can buy them in booklet form. We'll get to these procedures in this class soon.